So almost magically now, and this does feel kind of magical sometimes, we can move our dude around like in a game. In the previous video, we left off here, which gave us a sprite that was moving across the screen. And I changed the sprite to a guy with an axe. I think that looks a little nicer. And he moves across the screen, but he just keeps going. And our debug thing tells us that he's still moving, but we can't actually see him. So for most purposes, he might as well not be there. And it's actually worse than that because the computer is still having to track him, and it's still using like processing power to do this. So we don't want that to happen. We want him to either like bounce off the screen, or to stop, or to wrap back to the other corner, or like so that if he goes across the edge, he teleports over here like in asteroids. So that's what we're going to be attempting to do in this tutorial. And we're going to be expanding our use of variables by quite a bit. We're going to be making, you will see why variables are really good and cool and useful in much more detail in this tutorial. We're going to be learning how to do if statements, which are very important and allow you to do a lot more stuff. Like it's not that hard to learn the if statements, and once you know those, you'll be able to do a lot more. I kind of hope you played around with this and tried to do some stuff like this on your own. And if you did that, you probably felt pretty limited pretty quickly because you're lacking the syntax to really make anything too interesting happen. But once we get these if statements down, you really will be able to start doing a lot of little game stuff at the end of this tutorial. So I've switched over to Visual Studio now. I just think it's going to be easier to follow because I can use the mouse. There's going to be less like typing in terminal. And I would encourage you to keep using WordPad or something if you like that. But at some point, you're going to want to switch to something that has more functionality. When we start adding modules, which will be in the next lesson, you probably will not want to stick with WordPad, but you could. There's no reason you can't. Okay. So the first thing we're going to do right now is make some new variables. And the reason for this is we want to make a width. Whoops. This is one thing with Vim is sometimes, or with Visual Studio, is sometimes it does things you don't want it to, and it does it several times. Okay. Width equals. Okay, I was trying to keep it as a placeholder for demonstration purposes, but I'm going to type it out so that Visual Studio stops auto-correcting for me. Okay. So we're going to say width equals 1000, height equals 1000, and we're going to replace these with the variables. And this shouldn't be anything new to you because this is exactly what we did with sprite location X. It's the exact same concept. But I've done something incorrectly here. Maybe you can catch it. Probably you can't, but let's have a look and see what the error is. Actually, let me save this into the lesson2 directory so we can use that. Okay. What error are we going to get? We need to learn how to start reading these errors because no matter how good you get at coding, you're going to get errors all the time. And it's a real skill to figure out what the error is and fix it. So it says the error is in main.lua. That's our only file. :2. That's line 2. Bad argument number 1 to set mode. So argument number 1 is this. Argument number 2 is this. But the way it works is as soon as it encounters an error like this, it just stops and gives us the error. So actually, argument number 2 is also bad, but this just stops everything. And it says in more detail, number was expected, got nil. Nil is like none. Nil in this case means that width has literally no meaning to the code. And why does it have no meaning? Because we gave it meaning after we tried to use it. So to fix this error, we need to move these things in front of when we actually try to use them. Because this happens, then this happens, then this happens, right? So now if we run this again, it's fixed. Now, why did I do this? Well, there's a few reasons for it. The main one is that we're going to be coding things about keeping our sprite from going off the edges, basically. And the edges are 0, 0, 1000, 1000. So this is width and this is height. And we're going to be referencing 0 a lot, but 0 is never going to change. If we make the screen way bigger, this will still be 0 and this will still be 0. But these numbers might change if we eventually decide we want like a different aspect ratio or resolution or whatever. And our code is going to have a lot of references. If we don't use variables, we'll be saying 1000, 1000, 1000 a lot. And then not only 1000, but we're going to be having to do little adjustments. And what we want to have happen is when we change the screen size, or if we change the screen size, we can go in here and change it, and it will automatically adjust all of the code. Whereas if we don't have a variable, we have to go through manually and find like all the 1000s and make sure that they're not 1000 talking about something else, right? When our code gets really big, we might have 1000 that's not actually talking about the width, it's some other number. And we can't find and replace because we might accidentally break a bunch of stuff. But if we call it width, we know what it is, and we can adjust it with with a few keystrokes. So that's why we're doing that in preparation for all the code we're going to be doing. Now, we're going to make it so the sprite, before we try to do a wrap or a bounce, I want to make it so he just stops. He gets to the edge and stops. So we did this in the last video where I was like, before we even know the syntax and how the code works, think about how you would move it. Now think about how you would stop him from moving. And I mean, it's pretty obvious, right? Like if we get rid of this, he stops moving. So one thing I can show you now is this is the comment system. If you type dash dash, this is designed so that you can put comments on your code. If you're coding with other people, it's important to do this, and even for your own coding, like so that you remember what things are doing. You can do this to make notes for yourself, and the computer will ignore it. But another use of this is like when you're testing stuff, instead of deleting this, I can just comment it out, and run the code again, and it won't run that code. And so we can see our axe guy is just standing there because this isn't happening anymore. So that's how we stop him. But we don't want him to stop at the top left. We want him to stop at the bottom right. So we wanted to keep doing this until he is here. So what would you do? Like, what is the math for that? Basically, in the wording of an if statement, if his position is greater than width, if his x position is greater than width, if his y position is greater than height, then we don't want to do this anymore. So let me show you how to do this. So the syntax for an if statement, we say if sprite location x is less than width, then. So you have to say if, and then this is your condition, then, and then you indent the thing that happens and you say end. We say if condition, then. So basically, if whatever we put here is true, this will happen. So as long as sprite location x is less than the width, this will happen. And it's running every frame, right? So eventually it's going to reach a point where the sprite location x is greater than the width. And when this happens, it's going to go, okay, don't do this anymore. And it's just not going to move anymore. It's going to stop. We also want to do this for the y. We technically don't really need to because it's going directly into the corner and the x will stop it as well. But just to be cleaner, let's do it for the y as well. So I think that is pretty clear. That should make sense, right? Let's make sure that it works. Is he going to stop? Okay, did it work? Sort of, yes. How do we know it worked? Look at the debug. He stopped, right? But why did he stop off screen and why did he stop at 1002? Well, basically, this, he's moving 3, so he was at 999 and it ran this, and then he went to 1002 and then it went through again and then it ran again and then it finally said, okay, he's at 1002, don't move anymore. But 1002 is a little bit off the screen and we can't see him at all. In order to fix that, there's a few things we can do. I mean, and this is what happens a lot in coding, where you have a little issue like this actually did exactly what we wanted it to, but until we tested it, we didn't realize that we couldn't see him. So we're going to say like width -10, height -10, and that will stop the sprite a little bit before he actually hits the corner. And it might not be enough, so let's see if it's enough. No, we can see his cheek. He's at 990 now, but that's still too far off. So let's try like 35. Okay, perfect. So he stops at the edge. He's just like, okay, I'm there. I'm done. I'm not moving anymore. So that worked. But this is a little bit, I mean, this is as far as I really want to go with the stopping right now. But I do want to show you, what if we put him, like, let's say we want to do it the other way now. He starts, instead of starting at 0, he starts at width, height, and he moves in the other direction. So why isn't this working? Well, we can see he's stopping, and that's because of this. So in order to get him out of this kind of trap, we could say width -36. minus 36. And that will get him out of the if statement that stops him. But we didn't actually code anything to stop on this corner, so he just keeps going. And we could fix it, but the thing is, we are hard coding his movement, and like this doesn't really it doesn't really make sense to try to generalize this because we're telling him to move in a certain direction and we know where he's going to hit the wall. So like I don't need to code like all the walls that he's going to hit. I would just need to code these in this case. If you want, you can try to do that on your own, just like as an exercise. I'm not going to do it here though, because I've kind of made my point with how you would do a stop. And we'll do some more stop stuff later when we put the keyboard controls in at the end of the video. But we have to cover wrapping and bouncing still. And I think that's we're just gonna go ahead and do that. Okay. So for doing a wrap, we'll keep the 35. Well, so for wrapping, would we want him to visually be teleporting or not? I would say no. So I'm just going to remove that 35 thing. We don't need the 35 anymore. And we also, really, we don't want any of this. Let's just get rid of everything because we don't want his movement to be a conditional thing anymore. What we actually want to have happen is when he's always going to be moving. Okay, so he is always going to be moving. Let's say, yeah, so just sprite location x equals and this is going to be 0 again. Do +3. The 1 is too slow. So just making sure everything is still going normal there. Yeah. So what we want to have happen now is this is always going to happen, but we want to add in an if statement. If sprite location x is greater than width, then, and so what do we actually want to happen? Well, basically we want to make him teleport to the other side of the screen, which would mean we're going to set the sprite location to the other side of the screen. How would you do that? Well, remember that the equal sign is like a verb. It is a declaration. So we're just going to say sprite location x equals sprite location x minus width. Now, does it make sense what's happening there? Like, basically, wherever he hits on this edge, because the condition is that if he exceeds the width, which is basically saying if he hits this right edge of the screen, then his location immediately changes, is immediately subtracted by 1000, which teleports him directly across horizontally, right? And then we say if sprite location y is greater than height, then right? Does that make sense? Let's see if it works at least. Yeah. So now he's wrapping. Let's do a few things though. Let's check and see if he's not hitting the corner. What does it look like? Is that right? Why do I feel like this isn't actually a square? I think this is right. This is how we want it to behave. I do feel like for some reason, my computer is making this more, it looks taller than it is wide. I don't know if that's just my eyes playing tricks on me. I don't think it is. I think my computer is like, I didn't notice that until now, but I'm not going to worry too much about that. But I think that's making it look a little bit janky just because the aspect ratio isn't quite right. We know it's right because of the coordinates and stuff, but it just still looks to me like my computer is displaying it a little bit taller than it should be for some reason. Okay, so he's wrapping. Let's put him. Let me show you another thing you can do. Now with these variables, we can say width divided by 2, height divided by 2, and that will start him in the middle of the screen, which is good, which is better for testing this stuff because we can just like minus it now, and he can go in the other direction and not start in the corner. Oh, that doesn't work. What happened? Well, yeah, we only accounted for a greater than. We didn't account for that. So what do we need to do then? Well, another if statement, we can say if is less than 0. Instead of with minus, we do. So if it goes off the left side of the screen, we want to increase it by 1,000. We do plus width. And I'm really bad at wrapping my brain around this kind of stuff. I generally just give it my first gut instinct, and I think I'm right, and maybe I'm right. I don't know. I test it out and see if I'm right or not. And if I'm wrong, I find it easier just to test if I'm right or wrong. And I'm still wrong somehow. That didn't work. So what happened wrong there? I actually spent like 5 minutes off camera trying to figure out what was wrong here. I used the little debug tactic that is kind of. I'll make a cleaner debug thing later when we get more complicated. But this is a little debug thing you can do where I was trying to see why it wasn't happening. So I first wanted to check whether the if statement was triggering or not, because that it could either be that this wasn't triggering or something was wrong here, and I wanted to know which it was. So I write test1 equals yo, and then in draw I say if test1, then print test1 basically. If test1 is shorthand for if this variable exists at all. Because if I don't put it, it will give me an error. If I just say print test1, it will give me an error because it will say there's nothing to print. But so we have to put that in an if statement. So I did this and I see it say yo. I mean, it's over top of this other thing because I was too lazy to move it down, but I know it. I know the thing triggered. So now I was like, okay, don't worry about this. What's wrong with this? Well, I typed sprite location y. I didn't type sprite location y. Pretty stupid. And it took me, somehow I just didn't see it. And I had to, and that just happens sometimes. So let's fix that and see if we got it working now. Yeah. Okay. So now we can see that, and regardless of which edge of the screen it hits, it does wrap. Okay. Now let's try to bounce it off the wall. So do we need any of this anymore? I'm trying to think if I just want to delete this and start clean, or if I want to reuse this. Let's try to keep it for now, because we do have these same conditions, right? So now what do we want to have happen? Well, again, let's remove ourselves from the coding language and just think about it logically. We have our sprite moving and it touches any edge of the screen. What do we actually want to happen? We want it to go in the other direction. We want it to bounce off and just go in the other direction. So what does that mean in math? Well, we basically want to flip these. We want it to become +3 or +5, depending on which wall it hits. So how do you do that? Well, we're running into kind of the same problem we had in lesson 1, where we didn't really have a way to modify these numbers because of the way the loop works. And once again, the answer is going to be to create a new variable, which we are going to call sprite speed equals 3. I'm trying to think. This won't let me move it off diagonals. We could do sprite speed X and sprite speed Y. Let's just do sprite speed for now. And let's just make sure this is working. So we're replacing numbers with variables. I don't know if this is going to give me an error or not. If it is, I might delete it. No error, cool. Okay, so that is still working. He's moving from this variable now rather than the hard-coded number. So now that we have a sprite speed variable, we can do something with it. So if sprite location X is greater than width, which is saying if the sprite touches the right side of the screen, then we want him to stop moving to the right and move to the left, which means sprite speed equals sprite speed times -1, right? Because we multiply by -1, that just inverts the operation symbol from either minus to plus or plus to minus. And let's do that for everything. Is that going to work? Let's think about it. It didn't work, and this is a really interesting bug, actually, where if I move him to like if I just offset his position like a little bit so that he doesn't hit the corner exactly. Now it works. And this is a weird one where like you might like if you weren't coding him to hit the corner, you might think, oh cool, my code works. And then at some point he would hit the corner and it wouldn't work. The reason it doesn't work when he hits the corner is because it's doing everything in order, right? So it's saying if X, he's hitting the top left corner, that's X is less than 0, and also Y is less than 0. So what's happening is the update function goes, okay, is this happening? No. Is this happening? Yes. It multiplies it by -1. Is this happening? No. Is this happening? Yes. It multiplies it by -1, and then it draws. And so it multiplies by -1 twice, which is effectively doing nothing. Generally speaking, whenever you have in code, like if you write the same thing 4 times, you're probably not doing something right. that's a lot of the time like a hint that something isn't ideal. So what we can do here is just say if sprite location X is greater than width, or sprite location Y. I'm trying to think. We need to make sure that this is never happening at the same time. So we either couple like X and Y together or both X's together. I'm trying to think. I think we couple X and Y together, right? Because the corner is always going to be X and Y. Or sprite location Y is greater than height. Then do that. We could also just say, I think we can, I'm trying to think if there's any reason we can't just do it all as one statement. I think we can do this. You have to be careful with or statements, by the way, because what this is actually doing is it's just going to check if any one of these is true. And as soon as one of them is true, it will just stop reading the rest of them and do the thing, which in this case, I believe is what we actually want to have happen. But there will be cases where you think to yourself as a human being that speaks English, you're thinking of or, and it's not going to be the way you want it to be. It's going to be something else. So that's still working with the offset. Does it work in the corner now? Let's check. Yes, good. So we fixed the problem. Now, I'm trying to think what else let's like, let's do sprite speed X and Y maybe. No, we don't need to. I think this is exhaustive enough that you get the idea and that we can, we could code it so that we could put a few guys on the screen and have them all bouncing around. There's a few things we could do, but I think this really shows you it, and we don't need to dwell too much on it. So that's good. And now we're going to finish off by doing keyboard controls, which is kind of exciting because it is the most game-like feeling thing we're going to have done so far. So we can go ahead and delete this. I want to leave this in for a bit to show you something. But so keyboard, we're going to be just using these Love2D functions that are built in here to check the keyboard inputs. And there's a specific syntax for it. And there's really not much to it. Surprisingly, like making it so that you can control a character is much, much easier to code than telling a character to go somewhere and requiring them to move on their own and stuff like. It's much easier to directly control a character. So we're going to say if love.keyboard dot is down parentheses quote. Let's start with the x-axis left, then sprite location x equals. Think about this for a second. Don't just be like, oh yeah, I got it. Like really think about it. You know this, right? Like what would you put, right? You should know it. Minus what? Sprite speed. And you can see how this variable is very useful now, because once we code this in, if we want to change the speed of our sprite, we can just change one number. Whereas we would otherwise have to do this like 4 times. If love.keyboard is down. And by the way, I'm a really big fan of manually typing this stuff out until you just know it. Like if you copy paste this, you're not going to learn the syntax and you're going to have to look it up like over and over and over. Plus sprite speed. By the way, Lua is case sensitive. So if I type like sprite speed with a lowercase, it's not going to work. That's an important thing that you need to remember. And it will get more important as time goes on. Up. And we have to pause a second, and because the axis is so in the top left, up would mean that we are subtracting, right? We're subtracting sprite speed. And this down thing might be confusing you. Down is just referring to like the key is down. You press a key and it moves down. It's not like down arrow or something. Okay, so almost magically now, and this does feel kind of magical sometimes, we can move our dude around like in a game. We put in like 4 if statements and we can fully control our axe guy now. We can make him move faster by increasing his speed. Now he's like a berserker or something. But now I've left in this code for the wall wrap. What happens? We can test our bouncing now because we can test it on any. The problem is, and you can't see this, but as soon as I touch the wall, my controls invert. When I touch this wall, it makes sense because if I'm holding down right, I keep bouncing. But if I let go right now and I press up, I go down. Because think about it, as soon as I touch the wall, the sprite speed variable gets multiplied by -1 and that happens. So that's not an intended behavior that we would ever want in a game, I don't think, unless you were doing some kind of goofy mechanic like that intentionally to make it harder maybe. But having a bounce effect actually makes no sense, really, when you're controlling with the keyboard. Um, having a wrap function would make a good amount of sense. I deleted the code for the wrap, so we're not going to do that. But let's finish off with having it so that we stop when we hit the edge of the wall, because I think that makes the most sense. Like you pretend that the edge of the screen is like a wall, like in Zelda or something, and we can't go any further. So what we can do is we can just say if love.keyboard is down left and sprite location x is, so left would be, this is 0. We need it to be greater than 0. Greater than 0. And then this one, and sprite location x, right side is width. It needs to be less than width. And sprite location y up is 0. It needs to be greater than 0. And you can see the echoing of the code kind of happening here. And sprite location y down is height, and it needs to be less than height. So we kind of double up these if statements, and now our guy is unable to pass the wall. And what we're kind of seeing here happen is the sprite is kind of offset a little bit somehow, like just because of the way it's drawn. And it looks okay on the top left and on the top and bottom, but this doesn't look good. And we saw that earlier when we were moving him here. So we would want to clean this up a little bit, like right and down are not what we want. We would do like with, we previously established -35 was about right. So if we do that, it's not quite right. Like this should be maybe, this needs to be 40 and this needs to be, wait, is that 40? This needs to be 40. This needs to be 30, I think. This is good. This needs to be like 25, 22. I'm just going to guess 22. That feels right. Good. And, you know, if we really wanted to clean it up, like this is not quite right either. So on the left, we would want it to be, that looks like about 12 to me. No. 7. That's about right. And this should be like 7 probably still. Yeah, that's about right. I mean, and you know, if you were really trying to make a game here, you would want it to be quite perfect so that it feels about the same. This is close, I would say. It feels nice. I'm just a big fan of like when you're trying to make stuff, to make like, even if you're prototyping it, like, you know, make your, instead of making him an O, make him like a little guy with an axe. Make sure you have things behaving cleanly so that you can practice doing that, and you can get the satisfaction of having it look good. And that's all we're going to do for this tutorial. In part 3, we're going to start looking at functions, which will allow us to do a lot of cool stuff. And yeah, it will let us do a lot of cool stuff, and we'll try to play around some and put in some little gameplay elements instead of just moving around on the screen. So thank you for watching. Let me know if you have any questions, comments, feedback. I appreciate it. Thanks for watching.